Program to find largest of 10 numbers. 10 numbers are stored at internal RAM location starting from address 12H. Write a program to find largest of these 10 numbers and store result in accumulator. As an example, I have written here 10 memory locations, and suppose N1, N2, N3, these are the numbers stored at this memory location. We have to find largest of these 10 numbers. So for that, use R0 as a pointer to first memory location. We'll read this number N1 and we'll store it in accumulator. Then we'll increment this R0. So R0 will point to next memory location 13H. We will read this number N2 and will store in any register, for example say R6. So first number is stored in accumulator and second number is stored in R6. Now we'll compare these two numbers which are stored in accumulator and R6. So if a number stored in accumulator is greater than number stored in R6, the contents of accumulator and R6 will remain as it is. But if accumulator contents are less than contents of register R6, that means the larger number is stored in R6, so we'll store the contents of R6 in accumulator. That means we'll move the contents of R6 in accumulator so that the larger number will always stored in accumulator. After this, we'll increment R0 again. Now larger number is in accumulator, so next number again will move in register R6. Now again we'll compare contents of R6 and larger number which is stored in accumulator. If now accumulator contents are greater than R6, we won't do anything. But if accumulator contents will be less than R6, we have to move contents of R6 in accumulator so that the larger of these two numbers will be stored in accumulator. We'll increment this R0 again and we'll repeat these steps 9 times because we are comparing two numbers at a time. So we have to repeat these steps 9 times, and for that we have to initialize the counter with 9 so that we can repeat it 9 times. Let us understand flow chart for this program. So first we have to initialize the counter to 9 because we are going to repeat the same steps 9 times. So for that you can use any register. I'll use here register R7. So R7 should be initialized with number 9. After that we'll use register R0 to pointer to first memory address, that is 12H. So 12H address will be stored in register R0. Next is we'll copy contents of this memory location 12H pointed by R0 in accumulator. So for that we have to use indirect addressing mode, that is move a comma at R0. So content pointed by R0 will be stored in accumulator. After that we'll increment contents of R0. So now in this time R0 will point to next memory location, that is 13H. Next step is copy the contents of memory location pointed by R0, which is 13H, into register R6. So for that we can use instruction move R6 comma at R0. So next memory location number is stored in register R6. Next is we want to compare contents of accumulator and R6. If contents of accumulator are greater than R6, then larger number is already in accumulator. But if contents of accumulator are less than R6, then we have to move larger number which is in R6 into accumulator. So to compare and check this, we'll use instruction CJNE. So we'll compare and jump not equal, we'll compare accumulator and register R6 content. Since it is direct addressing mode, we'll write here address of register R6. So it will compare accumulator and contents of R6, and if not equal, it will jump to label. I am writing here label L1. So after that we'll compare whether contents of accumulator are greater than contents of R6 or not. For that we have to check a carry flag, that is borrow flag, because compare instruction subtract the contents of register R6 from accumulator, and according to this operation the carry flag, which is used as a borrow flag, will set or reset. So if accumulator contents will be greater than register R6, then no need of borrow, so carry flag will be 0. But if accumulator content will be less than R6, then there is need of borrow and carry flag will set to 1. So here we'll check whether accumulator contents are greater than R6 or not. If accumulator contents are greater than R6, S, that means carry flag is 0. And if accumulator contents are greater than R6, no need to do anything. Larger number is in accumulator, will directly decrement the counter, that is register R7. So we have to decrement register R7 because we have completed this operation one time. If accumulator contents are not greater than R6, that means carry flag is set to 1, then larger number is in register R6, so we'll move contents of R6 into accumulator. So we'll use simple instruction move accumulator comma R6, move contents of R6 into accumulator. After this operation is performed one time, so we'll decrement counter, that is register R7, and we'll check whether this counter is 0 or not. If counter is 0, then larger number is in accumulator and will end the program. So if counter is not 0, first we'll again increment R0. So now contents of R0 or R0 will point to next memory, that is 14H. We'll read this contents of memory location 14H stored in register R6, and again we'll repeat the same step, that is compare accumulator and R6. Now write assembly language program to find largest of 10 numbers stored at internal RAM memory location. So for that first we'll initialize counter. So R7 register we are using as a counter, will initialize to 09H to repeat these steps 9 times. Next is we'll use a pointer. Register R0 will point to first memory location 12H. Next we'll move the contents of this memory location 12H and store it into accumulator. So we'll use indirect addressing mode, move a comma at R0. So first number is stored in accumulator. Then we'll increment this pointer, so INC R0, and we'll move the contents of memory location pointed by R0 in register R6. So move R6 comma at R0. So second number is now stored in register R6. Now we want to compare accumulator contents and R6 content. So for that we'll use instruction CJNE compare accumulator with register R7. So compare and jump not equal to label. So I'll write here label L1. If contents of accumulator and R6 are not equal, it will move to label L1. If contents are not equal, that means accumulator may be greater than R6 or accumulator contents may be less than R6. So I will check a carry flag, that is actually borrow flag. So I'll write here instruction jump no carry. If carry is not generated, then get to other label, that is L2. But if carry is there, we know that contents of accumulator are less than R6, so we want to move contents of R6 into accumulator. So move contents of R6 into accumulator if there is a carry. And after this we want to decrement a counter, so write decrement and jump not 0 counter, that is R7. If it is not 0, we want to repeat this process. So I'll write here label back. Back label should be given to increment R0 so that R0 will point to next memory location. Now here, if accumulator and R6 contents are not equal, then we are going to check a carry flag. But if they are equal, we want to directly decrement R7. So here I'll write unconditional jump instruction, that is S jump instruction, and jump to label L2. So L2 label I'll give to this DJ and Z. So if accumulator and R6 contents are equal, it will execute next instruction, decrement a counter. If counter is not 0, it will again go to back label and repeat this process. If this process is repeated 9 times, that means if R7 contents are 0, we want to stop program and larger number will be stored in accumulator. To stop this program, we'll write this exit loop. So here I'll write S jump exit.